All right, guys, I'm just going to go over the review. I'm just going to kind of talk my way through this. So if you still have questions after this, please let me know. Um, so this first part, we're solving by taking square roots. Um, if it doesn't tell you to solve by taking square roots, you can really do it anytime you have p squared or an x squared and just constant terms. When you cannot solve by square root is when you have both a p squared and a p somewhere in the equation. Okay, then you would not be able to solve by taking square roots. So remember, to solve by square roots, all you need to do is get the squared term all by itself on one side. So in this case, we got to get this -4 and move it away from p squared. So we're going to add 4 to both sides. So this will give me p squared equals 24. And then we just need to take the square root of both sides. The square and square root cancel each other out. Remember that you're going to have a positive and a negative of your solution each time that you're taking the square root of a variable squared. And then 24 breaks down to 2 times 12, 2 being prime, and then 12 is 4 times 3, and 3 is prime. And then 2 times 2 is 4. And then we're looking, since this is a square root, we're looking for pairs. So there's a pair of 2's right there. So I'm going to pull a 2 out front. This other 2 and 3, since they don't have any match, I'm going to multiply them back together and they're going to stay underneath. So p equals plus or minus 2 square roots of 6. Number 2, again, we need to get n squared all by itself on one side. So we have to undo anything that's on the same side of the equation with n squared. So in this case, we're subtracting 3 from both sides, which gives me n squared equals 9. Take the square root, and n could be 3, positive 3, or negative 3. 3 times 3 is 9. Also, negative 3 times negative 3 is 9. On number 3, we're going to divide both sides by -6 because, again, we're trying to get x squared all by itself on this side. So we're going to get rid of times -6 by dividing by -6. 288 divided by 6. Let me grab my calculator here. Oops. 288 divided by 6 is 48, so it's -48. Okay, I'm taking the square root of both sides again. Here the square and square root cancel. I have a negative under my square root. Again, it could be positive or negative, so I'm going to stick that in front. For the negative under the square root, I'm going to pull out an I, and then I have my 48. Now 48 will simplify a little bit. It is 4 times 12, and then 4 is 2 and 2. 12 is 4 and 3, and then 4 is 2 and 2. So in this case, I have a pair of 2's here and a pair of 2's here, which means I can pull out 2 twice. Remember, I multiply them together. So I'm going to have a 2i on the outside, and then this 3 right here would have to stay inside. So plus or minus 2i square roots of 3. On number 4, just divide both sides by 4. N squared equals -4. Taking the square root of 4, which is 2, but then again there was a negative underneath, so that means it's going to be 2i. The plus or minus has to be there every time you're taking the square root of a variable squared. And remember, for any quadratic, you should always have 2 solutions, so a positive and a negative on the square root ones. Okay, this next section, we are finding all the zeros. So remember, if I have any number and I times it by another number and it equals 0, that means one of those numbers would have to be 0. So in order for this to be true, for it to equal 0, either 2x minus 3 would have to equal 0, or x minus 3 would have to equal 0. If either one of them equals 0, it's going to make this true. So there will be 2 solutions that will make it work. So if on this left one, I'm going to add 3 to both sides, and then divide by 2. So x equals 3/2 is one of my solutions. On this side, I would just add 3 to both sides. Okay, again, each factor, and this one there's 3 x's, each one needs to be set equal to 0, and then solved for x. That one is already solved, right? There's nothing with x. This one I would subtract 1. This one I would add 1 first, and then divide by 3. So x equals 1/3, 1, -1, and 0. So take each factor, set it equal to 0, and solve for x. So x equals 1. We're going to add 1 to both sides here and divide by 3. So x equals 1/3. Remember, if there's just a number out front with no x, that's not going to affect our zeros. We can't change that to a 0, right, by putting an x in there because it doesn't have a variable with it. It's just a 4. Okay, so here we would add 4 to both sides to get 5x equals 4 and divide by 5. So x equals 4/5. On this one, I add 1 to both sides and x equals 1. All right, the next section here, we need to divide by factoring. So we're going to be using x factoring, but remember, every time you're factoring, the first thing you need to check for is the greatest common factor. So on number 9, the common factor that they have, 2, -6, and 8, has a common factor of 2. So I'm going to pull that 2 out front. N squared minus 3n minus 4. And then I'm going to go ahead and x factor what's left inside. So remember that 2 is going to stay out front, but I can kind of ignore it now. I'm just looking at what's inside the parentheses. So if there's nothing in front of n, it's going to be a 1. So a is 1, b is -3, and c is -4. So remember, when I'm x factoring, up on the top, I want a times c, and then down here on the bottom, I want b. So a 1 times c, -4, is -4. And then b is -3. So remember, I'm looking for two numbers that multiply to -4 and sum to -3. So that would just be -4 and +1. So this becomes n minus 4 and n plus 1. Then remember, you always want to divide them by a, but in this case, a is 1, so that's not going to change anything. So now that I have it all nicely factored, I can now do just what we did on the problems above and just find the zeros. So set each factor equal to 0 and solve for the variable. So n equals 4 and n equals -1. Okay. On number 10, again, first thing we want to do is look for the greatest common factor. 3 goes evenly into each of these numbers, so I'm going to first pull a 3 out front. That's going to leave me with n squared plus 14n plus, grab my calculator, 144 divided by 3 is 48. And let's just make sure I did 42 divided by 3 correctly. Yes, 14. Okay, so then we have n squared plus 14n plus 48. Now I can x factor. A times c would be 1 times 48. B would be 14. So I'm looking for two numbers that multiply to 48 and at the same time add to 14. So that would be 6 times 8. 6 times 8 is 48, and 6 plus 8 is 14. So this would be n plus 6 and n plus 8. We would want to divide each of these by a, but a in this case is 1, so it's not changing anything. And then this does equal 0, right? So we need to find the zeros. N plus 6 equals 0 means that n equals -6. N plus 8 equals 0 means that n equals -8. So there's my two solutions. On number 11, this is not in standard form. In order for it to be in standard form, one side has to equal 0. We have to have the x squared term first, then the x term, and then the constant term, so that's actually okay. The only thing wrong is that I have this equals 6 instead of equals 0. So to fix that, I'm going to subtract 6 from both sides of the equation. So 7x squared plus 18x plus 8 equals 0. Now 7, 18, and 8 do not have any common factors, and so we cannot pull out a common factor this time. So we're going to go straight to x factoring. So a is 7, and c is 8, and 7 times 8 is 56. So I need two numbers that multiply to 56 and add to 18. So let me go ahead and grab my calculator. So let's see, 56 divided by 2 is 28. So 28 and 2 will not add to 18. 56 divided by 9, nope. 56 divided by, okay, so I've tried 4 here and 14. So 4 times 14 equals 56. 4 plus 14 equals 18. So now we're going to go ahead and write this in factored form. So I have x plus 4 and x plus 14. A was 7 here, so I need to divide each of these by 7. Now 7 and 4 will not reduce, and it does not go evenly in, so that 7 is going to go in front of x. And here it's going to go in evenly, and I'll get x plus 2. Now set each of these equal to 0. Now here, when I'm actually solving, sometimes it actually just creates more work when I move that 7 in front. Because really, if I'm solving, I'm just going to change the sign of this. It would be -4/7. It's the same thing I'm going to get when I set this equal to 0 and solve for x. So if you are solving, not just factoring, if it just asks you to factor and leave it in factored form, I would put that 7 in front of x. If you're actually solving, once you get to this point, you can just change the sign of those as long as there's nothing in front of x. Okay, so for x plus 2, that would just give me another solution of x equals -2. So -4/7 and -2. Okay, 12 is also not in standard form. So to get it in standard form, I need to get this side equal to 0. So I'm going to subtract 32 from both sides. Now remember, I can't actually combine this 32 with anything because I don't have any like terms over here. But I do need it in standard form where my r squared comes first, then the r term, and then the constant term. No common factors, so I'm going to go straight to x factoring. A is 1, c is -32, so I need two numbers that multiply to -32 and add to 4. So 8 and 4 would work. I would want the 4 negatives, since when I add these together, I need to get a +4. So this would be r plus 8 and r minus 4. I would want to divide by a, but a is 1. So r equals -8 and +4. All right, next section, we want to find the discriminant, and then we want to state the number and type of solution. So remember, the discriminant is b squared minus 4 times a times c. So I need to find the discriminant. Then remember, if I get a positive discriminant, there are going to be 2 real solutions. If I get a negative discriminant, there's going to be 2 imaginary solutions. If my discriminant is 0, there's going to be 1 real solution. So again, it's technically 2 solutions, but they're both the same. So that's why we say 1 real solution. All right, so let's start with number 13. The first thing we want to do is make sure it's in standard form, and this one is. We have our b squared, and then our b, and then our constant, and then the other side equals 0. So let's go ahead and just write down what a, b, and c are. So a is 8, b is 9, and c is 9. So b squared would be 9 squared minus 4 times a, which is 8, times c, which is 9. So 9 squared is 81. 4 times 8 times 9, I'm just going to use my calculator for that really quickly. So 4 times 8 times 9 is equal to 288. So I have 81 minus 288, which gives me -207. So there's my discriminant. It's a negative number. Because my discriminant is negative, I know there's going to be 2 imaginary solutions. Okay, so let's try number 14. Again, it's in standard form. One side is equal to 0. So I have a is -4 and b is 3. C is missing, so in that case it is 0. So plug a, b, and c into our discriminant formula. 3 squared minus 4 times a times c. So 3 squared is 9. I have a times 0 here on this second part, so that's going to all go to 0. So 9 minus 0 is 9. So my discriminant is 9. 9 is a positive number, so there are going to be 2 real solutions. All right, so number 15 is not in standard form because I have equals -8 over here. So I'm going to start by adding 8 to both sides. Since 8 and -9 are like terms, I can combine them. So -9 plus 8 is -1. So now that it's in standard form, I can find my A, which is -1, my B, which is 2, and my C, which is -1. So B squared would be 2 squared minus 4 times A times C. So 2 squared is 4. I'm subtracting here, but I have 4 times -1 times -1. So because here I'm multiplying a negative times a negative, and then I'm also multiplying it by -4, this is going to end up being a -4. So -4 times -1 is +4, but then +4 times -1 gives me -4. So 4 minus 4, which is 0. So when my discriminant ends up being 0, that means I have one real solution. So it's one real repeat solution, right? Number 16, not in standard form, so I'm going to add 3 to both sides to get it there. So -2n squared minus n plus 3 equals 0. A is -2. Whoops, I meant to put equals there. B equals -1 and C is 3. So B squared would be -1 squared minus 4 times A times C. So -1 times -1 is +1. -4 times -2 is 8, and 8 times 3 is 24. So my discriminant here is 25, and that's a positive number, so there will be 2 real solutions. Okay. So quadratic formula. First thing again is make sure it's in standard form. We're going to find A, B, and C, and we're going to find that discriminant. Then we're going to plug it into the rest of our formula, which is -b plus or minus the square root of a discriminant all over 2 times A. Okay, so on number 17, it's already in standard form. One side's equal to 0. We have an n term that is missing. So technically we could solve this using square roots, but it asks us to use quadratic formula, so we're going to do quadratic formula. A is equal to 8. B is 0, because remember it's that middle term, that n term that's gone, and that's the one that has B. And then C is -22. So let's first find the discriminant. B squared minus 4 times A times C. This would give me 0, and again here I'm multiplying -4 times 8, which would be -32, and then -32 times -22 will make it positive, and that's going to give me 704. Let's just double check that. Yeah, so it'll become +0 plus 704. So my discriminant is 704. So now I'm going to take this and plug it into the bigger formula here. So -b would be -0 plus or minus the square root of 704 all over 2 times A, and A was 8. So plus or minus square root 704 over 16. Now we're going to break 704 down. Let me quickly just make sure that that's not, okay. So 704, let's divide that by 2 first. So 2, which is prime, times 352. Okay, and then 352 divided by 2 is 176, which would be 2 times 88, which is 8 times 11, 2 and 4, and 2 and 2. So we're looking for pairs. There's 1 pair of 2s, 2 pair of 2s, and 3 pair of 2s. So I have 2 times 2 times 2 that's going to come out front, which would be plus or minus 8. 2 times 2 is 4, 4 times 2 is 8. And then that 11 is going to stay underneath the square root. So I have plus or minus 8 square roots of 11 over 16. And then 8 over 16, that will reduce. So I have square root of 11 over 2. So plus or minus square root of 11 over 2. Okay, number 18 is also already in standard form, so let's just write down A, B, and C. Okay, and then we're going to plug it into the discriminant, so b squared minus 4 times a times c. So that would be 100. 4 times 4 is 16, and 16 times 6, let me grab my calculator, is 96. So 100 minus 96 equals 4. My discriminant is 4. So let's plug into the quadratic formula. So negative 10 plus or minus the square root of 4 all over 2 times 4. So I was just simplifying that. I've got negative 10 becomes positive 10 plus or minus the square root of 4, which is just 2 over 8. So because my square root on this one went away altogether, I can break this into 2 separate problems and solve them individually. So 10 plus 2 over 8 and 10 minus 2 over 8. So this becomes 12 over 8, which will reduce down. 4 goes into 12 3 times, and it goes into 8 2 times. So 3/2 is one solution. 10 minus 2 is 8 over 8. That will equal 1. So I have 3/2 and 1. Okay, last two. This one, number 19, is not in standard form. And so we're going to go ahead and change it to standard form. I'm going to change colors just because my writing is kind of leaked here and I don't want to get confusing. All right, so let's first start by adding 5 to both sides of the equation. So 8x squared minus 5x plus 5 equals 0. Now I'm going to just write down what a, b, and c are. So a is 8, b is negative 5, and c is 5. Find my discriminant would be negative 5 squared minus 4 times a times c. This is 25 minus 4 times 5 is 20, and 20 times 8 is 160. So that would give me negative 135. So I have a negative discriminant, which means I'm going to have some imaginary solutions here. Now I'm just plugging into the quadratic formula. So negative 5 plus or minus the square root of negative 135 all over 2 times a. So that would be 5 plus or minus I square roots of 135 over 16. And then we can go ahead and break down 135. That would be 5 times, I'll go in, is it 20? Let's see. Just do it really quickly and then I won't have to get it wrong. 5 by 5 is 27. And then 27 is 3 times 9, and 9 is 3 times 3. So it looks like we can pull out a 3, which would give me 5 plus or minus 3i square roots of, what's still left under here? We got 3 times 5, so 15 over 16. And since 5, 3, and 16 have no common factors, we can't simplify that anymore. So that would just be our answer. All right, last one, number 20. Again, we have to get it in standard form before we begin, so we add 3 to both sides. 3x squared plus 5x plus 3 equals 0. A is 3, b is 5, and c is 3. The discriminant would be b squared, which is 5, minus 4 times a times c. So 25 minus 9 times 4, 36, which gives me a negative 11. And then we plug into our bigger formula, so negative b plus or minus the square root of negative 11 over 2 times a. So I can simplify each of these just a smidge, so that would just be negative 5 plus or minus I roots of 11 over 6. Again, since I don't have a common factor here in front of the square root and down here, I can't simplify that anymore, so I would just leave my answer like that. All right, guys, I hope that helps. If you have any further questions, just email me.